Hey everybody, it's time we learn one extra little piece of math here called alligation. Now alligation is a problem that you'll use to figure out a certain word problem where we have two different percentages of a cream or a solution and try to get some percentage that lies in between the two of them. I want you to be proficient in solving these because you'll almost certainly have a problem like this on your exam. If you're in either a compounding lab or some certain institutional, such as hospital settings, you may have to do this as well. It can be math intensive. It really is just a simple concept, but you have to know how to set up the problem. You'll want to be somewhat proficient in it to be able to do it kind of fast as well. So when is it needed? It's when I have a certain percentage strength of one product and another percentage strength of the same product, but maybe there's a percentage in the middle between the two of them that's not available. So you can mix the two strengths together to get that strength that's in the middle. So one higher strength, one lower strength, and it'll tell us how much. This alligation problem will tell us how much of each one to use. So let me just think off the top of my head. Let's say I have a 10% solution and a 20% solution, and the doctor calls for a 12% solution. So how much of that 10% solution and how much of that 20% solution am I going to use to be able to get to that 12%? So let's do a real world problem, or let's see how we're going to set this up first of all. The easiest way I can tell you to do it is we are going to draw a tic-tac-toe box. Okay, so tic-tac-toe box. We have nice tic-tac-toe game playing surface there, you can see. Don't get too distracted by its tic-tac-toe. The first thing you're going to do is you're going to get the strengths requested. So in my example earlier, the doctor requested a 12% solution. We'll put a 12 right there. The next step is in the upper left, you were going to put the strength of the higher percentage solution. So again, in my example, I said 20% we have available. So we'll put a 20% solution there. Then we will have the lower percentage solution. I said a 10% solution, so we'll put 10 there. So upper left I have 20%, lower left I have 10%, and in the middle there I have 12%. The next thing we do is we get the difference between the two of them. I'm going to get the difference between the 12% and the 10%, the difference between the two. Now notice I'm not saying just subtract one for the next one, because sometimes you'll get a negative number. If you get a negative number whenever you get the difference between the two of them, that's fine. Just take out that negative number. It's just the difference between them. So this one, 12 and 10, the difference is 2. On the other side, the lower right, I'm looking for the difference between the two, between the higher percentage and the strength that I'm looking for. So in this case, my example, it was 20 and 12. So what's the difference? It's 8. How are we going to set this up from this point? On here, I've got another example here where we're going to take it even a step further, okay? But I'm going to use a different set of numbers. So the first part is, let me just read the question to you. You have an order for 500 mils of 30% dextrose. You look at the shelf, it's not there. So you have 70% dextrose and 25% dextrose. Let's work through this to see how much of each one you're going to need to get that 30% dextrose. 30%, that's what we're looking for. Our higher percentage strength is, of course, 70%. 70%. And then our lower percentage strength that we have, that is what we discussed earlier, the 25%. So you know what to do next. We're going to find out what is the difference between those two. You could probably do the math in your head, but I've got no problem with you using a calculator should you need it. But 70 and 30, what's the difference? Well, it's 40. 40 parts. 25 and 30, what's the difference? Well, we already know it's 5. You can probably do that in your head. Again, if you need to use a calculator, I have no issue with that. So I have 5 parts there of 70% and 40 parts of 25%. Total parts we're going to have is 45 parts. Now that we know we have 5 parts of the 70%, 40 parts of the 25%, and 45 total parts, just by adding that right column together, I can move on to the next step. I have 5 parts out of the total 45. I'm going to multiply that times the 500 mils asked in the original question. If you'll remember, the original order said 500 mils. So 5 over 45 times 500, the answer to that is 55 mils of dextrose, 70%. Again, just go straight across on our tic-tac-toe board. The next one is 40 parts over 45 total parts. We'll multiply that again times the ordered amount of 500 total mils. That will get us a total of 444.4 mils of dextrose, 25%. When we mix those together, what percentage will we have? Ta-da! We will get 30% mixture together. Now this alligation works great with a water solution as well. What would you do when you have water? Let's say you needed a 7% solution and all you had available was a 10% solution. Well, you could mix 10 and 0%, water being 0%, and you'd mix it together to get that 7%. Let's look together at a handwritten example to just further beat this into your brain a little bit to understand how alligation works. Let's imagine for this question that a physician orders 1 liter of a 7% solution. You go to the shelf, and of course a 7% solution is not there, but a 10% solution is. Let's work through the math on how you will turn that 10% solution into a 7% solution, just like the physician has ordered. I'm going to write here what we want. We want 1 liter of 7%. I have a 10% solution, and what else will I have here? Actually, I will use 0% because I'm just going to mix it with some sterile water. So I'll be able to mix a 10% and a 0% to form a 7%. To start here, I'm going to write our familiar tic-tac-toe board. I'll put in the middle here what we're looking for, which is 7%. In our upper left, I will put the higher of the two percentages that we have, which is 10. In our lower corner here, I will put the lower percentage of what we have, which is 0. Now I'll find the difference between the two. The difference between 0 and 7 is 7. And the difference between 10 and 7 is 3. I'll add these two together, and the total parts I'll get is 10. And I'll write here, just so we're keeping track of things. Total parts is 10. So 7 of 10 parts, we'll use 10%. And 3 of 10 parts, we'll use 0%. I'm going to multiply this times 1,000 mils for each of these. And let's find out what we get here. For this top, I'll put 7 over 10, and I'll multiply times 1,000. And of course, I'll get 700. Right here, I have 3 over 10. I'll multiply that times 1,000, and I will get 300. And both of these are in mils. So there you have it. I will use 700 mils of the 10% solution and 300 mils of the 0% solution, and that will get me the 7% that the physician originally asked for. Adding these up together, 300 mils and 700 mils, and I will get the 1,000 mils, or 1 liter. I'll get that as well. And that is it. That's alligation. Be able to write the tic-tac-toe formation, know where to put the higher percentage strength, the lower percentage strength. It isn't always in percentage, so be aware of that. And then also in the middle, put what is ordered, what are you requested, and then also, of course, know how much. In our case that we first did on the slides, it was 500 mils. Also, look at the slides again as well as the Blackboard material again to be able to really just pound it in and really know it well. With that, I hope you learn alligation well. Again, that'll be another question or two you'll get right on the exam.